What do you think that mark means right there? So what am I saying? But I put it on the arc. So how do you think I'd write that? I'd write arc AB is what? Congruent to arc what? CD. So that means their measures are equal, and actually their lengths are equal as well. Do you think we can infer anything from that? Anything else? Huh? Absolutely. This chord is congruent to that chord. I just put two marks just to separate a little bit from it. If the arcs are congruent, the chords containing those arcs are what? Well, to add one more to it, and this should be kind of obvious, but if I was to draw the what? Central angles for each one. We talked about that basically yesterday. What do you think I can say about these two angles? This angle is also congruent to what? Congruent arcs equal what? Congruent chords. And congruent central angles. Because they're all related to each other, are they not? I think that's something that's pretty easy to next one. This is one of those ones that will seem different. What does this chord here look like it is to this one? Good. If a diameter, what does that mean? It goes through the center. Is perpendicular to another chord went ahead and put the ifs in black. then the diameter bisects that chord. So what am I going to use for marks here? Good, just seeing if you guys are listening. If a diameter, keyword is what? Diameter is perpendicular to a chord, it cuts that chord in half. It bisects it, so I need to put what? Means this is congruent to what? And it looks like it, doesn't it? That diameter also bisects the arc contained in that chord. So what does it also cut in half? That arc. And vice versa. What do I mean by that? That means converse, right? So basically, if I see that this happens, what do I know that they say that happens? What do I know what angle is created here? My hands are too fat to cover up the right angle sign. But basically, if that happens, I see a diameter cutting a chord in half. I know that the diameter and that chord have to be what? Perpendicular. Just the opposite, vice versa, right? Makes sense. One thing to remember is you'll see problems like this. Everybody look up here. Has the concept changed any? Huh? No. Every radius can become a diameter just by extending it, can it? Yes. So you'll see a lot of drawings like this to where you're going to use this same what? The same theorem, the same concept. But it'll be a what drawn? Radius instead of a what? Diameter. Makes sense? That's why I kind of do it like that and use the whiteout, because that helps it make sense that all you got to do is connect the dots, get a ruler and connect it, and it becomes a what? Diameter. So of course a radius in this same situation is going to bisect that chord as well, right? Here in a second I'll draw it back again. Now, another one. Next concept. And what you're going to find, it's a lot about this chapter, is we're going to have a lot of theorems of things, situations you've never thought of. But makes sense, and they happen because, let's face it, a circle is symmetric in every way. Okay. You guys will watch me draw these, you'll realize I'm being methodical for a reason. Now, That's the center of the circle, of course. If two chords are equidistant from the center of the circle, then those chords are congruent. In other words, AB would equal what? XY. Liam? How do I figure out the distance from a point to a line? Anybody? I always use this example. A plane flying over the ground. How do they measure how far it is off the ground? Straight down. In terms of geometry, what does straight down mean? Perpendicular, right. So, what we're basically saying here is that that distance has to equal what? That distance. This has to be what? If that's congruent to that, if this happens, see how they're equidistant from the center? Then same, right? Well, same's the wrong word. We'll say congruent. Make sense? This one's hard because people have problems remembering that when I talk about, you have no problem, because doesn't it make sense if they're both the same distance from the circle, then there's got to be the same amount of circle left, because a circle is symmetric all the way around. You see, as this thing, just watch the edges that touch here. As this gets closer to the center, what happens to the edges that are touching? It gets larger, doesn't it? So it makes sense that if they're the exact same distance from the center, the same amount would be what? Touching the outside of the circle. Agreed? Like I said, there's a lot of little things like that that happen. And guess what's going to happen in some of your homework? Don't draw this, but look. What could I do right here? Connect the dots, couldn't I? There's nothing in the world that says you can't connect the dots right there, is there? That's a what? Radius. This is a what? What kind of triangle? Which allows you to do wonderful things like use trig functions and Pythagorean's theorem and all kinds of really fun stuff, right? Special right triangles. Isn't it exciting? Okay, let's get our red books out. So these are our concepts for today. These are the things you need to build off of. These are the things that, in essence, when you're doing these, you ought to have these right beside you and realize, okay, I would imagine that my homework is going to have something to do with all these concepts, isn't it? And guys, do not get behind this week. We will test before spring break. Okay, basically we talked about three concepts today. Concept 1, 2, and 3, right? Concept 1 is what? If the chords are congruent, then the what? Arcs are congruent. Concept 2, if a diameter is perpendicular to a chord, it cuts the chord and the arcs in. Okay, concept 3, if two chords are equidistant, make a right angle, this distance is the same, then the chords have to be what? The same, or congruent, right? Those are our three concepts, concept 1, 2, or 3. Number 1, deal with concept 1, 2, or 3. 1 and 3, but both concepts 1 and 3 both have to deal with congruent chords, don't they? But concept 1 has to deal with that if the chords are congruent, the arcs are what? So X is what? Number 2, concept 1, isn't it? Chords are congruent, so the arcs are what? So what could I do to find X? What is this? How does this relate to this? Well, I mean, how does this relate to this? How does this relate to this?
They're the same.
They're the same. The same, another word for same, you can just put what? Equal. If they're the same, I put 1 on one side and this on the other. Now it's just a matter of what? Solving. X is equal to? Stop writing. I'll zoom out and you can write this all down. I'll zoom this whole thing out, this whole front page out. Okay, right here. How did they go backwards here? Instead of saying the chords are congruent, they said the arcs contained by those chords are what? What does that mean? How does this relate to this now?
It's still the same.
So, 36 is equal to?
2x.
You guys can solve that, can't you? Oh, now they put a bunch of stuff. Boy, they're trying to confuse you here. All you know is that this is congruent to this, right? So if this is x degrees, this is x degrees. So, how am I going to... So I go 60 minus 38. What do I get? 2. Okay, so there's 322 left for what? These two, and these two are what? The same. So what do I do? So 161, 161. Same concept here, isn't it? Okay. Measure of arc A to C is 71. What does that make arc B to C? Why? Because this is a diameter, isn't it? In essence, a radius or diameter, and it cuts it in. And so it cuts the arcs in what? Okay. So on 7 they asked for BC. This is concept what? 1, 2, or 3? It's 2 there. It's that second one, right? So B to C is what? Or arc BC. Okay, A to D. They say the radius is what? So that's here to here. It's 34. A to B is 60. So that makes this what? 30, and this one what? But you see how I drew this radius right here? What is this right here? It's a right triangle, isn't it? Where this side is 30, this side, that's a radius, right? So what does it have to be? 34, right? So AD is 30. Look, they asked for YD. They asked for this one right there. So what am I going to do? I already did the hard part for you. You know what the hard part was? Is realizing that you can draw a radius anywhere you want, can't you? And it stays the same no matter where it is. And that is a radius, from the center to the outside. So then I created a what type of triangle? Where I know the hypotenuse is 34, so 34 squared is equal to, one of the legs is 30, so 30 squared plus yd, so we'll call it what? X squared. Now I solve for this. What's 34 squared?
1156.
So 1156 minus 30 squared is what? 900 is equal to x squared. What's x squared equal to? 256. Take square root of both sides. What's x equal to? That came out nice and even. So yd is 16, yes.
David, I found a much easier way to find YD.
How?
YA is the radius, and so is YC. So, splitting that in half, you would just get 16.
No, you wouldn't. Splitting it in half, you'd get 17. And be careful of doing stuff like that, because sometimes it'll look like they are, you know what I mean? And it'll kind of take you to that. So, but you can't necessarily do that. There's no rule that says this has to be cut in half, because see, you could move this down here, and this could be a really small part left of the radius and a really big part. So unless they tell you, don't assume you cut this in half. You're pretty much always going to have to use Pythagorean's theorem here on ones like this. They asked for the arc AB, 142. BD, 30. And D to C. Now, since you found that that's 16, then that means that has to be 18. Number 14. Or either one of these. Let's go number 13. Number 13, they basically said that VW is 20. And these two are the same, right? So are these equidistant from the center, these two chords? What does concept 3 say to us? If chords are equidistant from the center, then they have to be congruent. So if VW is 20, what is X? YZ is 5X.
That's 4.
So 5X is equal to what? 20. So X is equal to 4. Over here, like I said, don't write. I'll zoom out and you can write down. They say that UZ is 2X minus 1. And they said that SZ is what? X plus 4. And they said that these arcs are congruent. Well, if these arcs are congruent, the what? This is a combination of concept 1 and concept 3, isn't it? Because these arcs are congruent, these what? TR has to be congruent to what? TV, meaning the distance from the centers have to be the same. So 2x plus 1 has to equal what? X plus 4.
2x minus 1.
Is it 2x minus 1? Thank you. So X is equal to what?
5.
Okay?